Imagine waking up on Earth 300 million years ago. Seriously, just picture it. You open your eyes, you look around, and you wouldn't recognize a single thing about the planet you were standing on. There would be no countries, absolutely zero cities, and not even the continents as we know them today. Instead, the entire world would just look completely different, almost like a totally alien landscape.
Okay, let's dive into this. What if I told you that all the continents were once connected as one giant landmass? It sounds a bit like the premise of a science fiction movie, right? But today, we're taking this explainer on a journey way back in time to uncover the incredibly dynamic and honestly mind-blowing history of Earth's ancient geography.
Part 1. The Giant Supercontinent. We're setting the clock way back to around 335 million years ago. And let me tell you, the Earth was a vastly different place back then. It was a time of rapid evolution, dramatic climate shifts, and a geographic layout that would completely disorient any modern mapmaker.
Back then, Earth had only one massive supercontinent. Its name? Pangaea. Now, I want you to really think about the sheer scale of this for a moment. This was a single, enormous landmass that stretched all the way from one absolute end of the planet to the other. Every single piece of land you can think of today was just mashed together into this one giant supercontinent.
And naturally, if all the land is pushed together into one spot, well, all the water has to be too. That brings us to Panthalassa. Because Pangaea was just one massive block of land, it was completely surrounded by one solitary giant ocean. Panthalassa was this endless, unbroken expanse of water that wrapped entirely around the rest of the globe.
So, what was actually going on in this world? It was wild. First off, there were no humans. We were nowhere to be found. Instead, towering ancient forests covered the immense landmass, and they were ruled by strange reptiles and early dinosaurs. Plus, because the land was just this unbroken, massive stretch, the global climate was totally alien from what we experience today. It created a really unique environment where life was just evolving at a crazy pace.
Part 2. Earth's Great Divide. Now, as we know from studying geology, nothing stays the same forever. Deep beneath Earth's surface, unimaginable heat and pressure caused gigantic tectonic plates to slowly shift and move.
And over millions of years, that deep, relentless movement caused the Great Split. Pangaea actually fractured into two massive new supercontinents. The northern landmass became known as Laurasia, and the massive southern block became Gondwana. Just like that, the single, unified supercontinent was officially no more. Let's move to and see how this built. Because the formation of our modern world was an agonizingly slow, step-by-step process. First, Pangaea splits into Laurasia and Gondwana. Second, those immense landmasses didn't just stop moving. They kept drifting apart across the globe over millions of years. And finally, through this ridiculously slow drift, they eventually separated and settled into the 7 distinct continents we know and live on today.
Now, what's really interesting about this slide is you might think this continental drift is just ancient history, right? A closed chapter from millions of years ago, but it actually isn't. Even as we speak, the continents are still moving. They drift just a few centimeters every single year. To put that into perspective, that's about the exact same speed that your fingernails grow. So the map is still changing, it's just happening a little too slowly for our human eyes to perceive in real time.
Part 3. India creates the Himalayas. To really grasp how dramatic this movement can be over deep time, let's zoom in on one of the most fascinating micro-narratives in all of geological history, the epic journey of India.
Just follow this incredible journey. 100 million years ago, India was actually part of that southern supercontinent, Gondwana, located far to the south of where it is now. Then it breaks off and begins drifting north, literally inching across an ancient ocean. Fast forward to 50 million years ago, and India absolutely slams into Asia. I mean, the impact was so incredibly powerful that it crumbled the Earth's crust and birthed the Himalayan mountains, the tallest mountain range on the entire planet. And, incredibly, because India is still pushing northward today, those mountains are actually still growing taller.
Part 4. The clues left behind. So, the crucial point is, how do scientists actually map out a world from hundreds of millions of years ago? Like, how do we know this really happened? The answer lies trapped right in the rocks and the physical evidence left behind.
And this brilliantly illustrates how ancient shifting drastically altered Earth's climate. Because continents were positioned entirely differently relative to the equator, places that are barren, dry deserts today were once covered by lush, vibrant tropical forests. And regions that are currently buried under miles of freezing ice? Believe it or not, they were once warm, tropical, and absolutely teeming with life.
But listen, the ultimate smoking gun here is the fossil record. Scientists have discovered identical fossils of the exact same plants and animals on continents that are now separated by thousands of kilometers of ocean. Think about it. If a specific ancient land reptile couldn't possibly swim across the Atlantic Ocean, how were its bones buried in both South America and Africa? It's because those lands were once physically connected. Finding those matching fossils across vast oceans was the definitive, undeniable proof that Pangaea truly existed.
So, to sum this all up, Earth never stops changing. Mountains continue to rise, oceans expand, and the continents continue their slow, silent journey across the globe. The map we are so incredibly familiar with today is literally just a single temporary chapter in an ongoing geological saga. Which brings us to a final, fascinating question to leave you with. If the continents are still moving today, what exactly will our planet's map look like 300 million years from now? Will a new Pangaea form? If you enjoyed this explainer on ancient geography, please hit that like button, subscribe to the channel, and let us know down in the comments what ancient mystery we should uncover next. Thanks for watching and keep learning.